On August 15, 1977, the Big Ear radio telescope recorded a signal originating from the Sagittarius constellation that lasted for precisely 72 seconds. The transmission arrived as a sequence of alphanumeric peaks, 6EQUJ5, a code so concentrated that the monitoring scientist famously circled it and wrote "Wow" on the datasheet. For decades, the public has been offered a specific explanation. This was a focused broadcast from a biological civilization attempting to bridge the distance between stars. But the signal's behavior suggests a different origin, a structural breach in the rendering framework of our reality. Under normal conditions, radio waves in deep space follow the laws of dispersion. They expand, lose energy, and eventually blur into background noise. This data suggests the WOW signal behaved more like a laser. It held a peak mathematical capacity for 72 seconds without any measurable degradation. If this were a beacon from a biological species, it would require a massive energy expenditure for a transmission that only occurred once and then vanished. This specific temporary duration of focused data mirrors the symptoms of a digital system error. To understand the transmission, we have to look past the physical void and analyze space-time as a computational data matrix. A diagnostic scan of the event begins with the signal's specific frequency, 1420 Megahertz. In physics, 1420 Megahertz is the resonant frequency of hydrogen, which is the most common element in the observable universe. In a simulated environment, a rendering engine requires a basic unit of information to synchronize its physics. Because hydrogen is the simplest building block of matter, its resonant frequency acts as the carrier wave for the universe's programming. The telescope intercepted the raw operational frequency of the simulation itself. The WOW signal was the sound of the matrix's baseline code temporarily exposing itself to the hardware. In open-world software, the system only generates the specific details and coordinates currently being observed to save processing power. This explains why the speed of light is a fixed limit. It represents the maximum clock speed of the simulation's core processor. When the Big Ear telescope locked onto that coordinate in Sagittarius, it scanned a sector of space-time in the middle of a real-time asset load. The 72-second signal indicates a memory leak, a buffer overflow where the server's background cache spilled into our observable reality. Once the central matrix detected the overflow, it initiated an automated security reset, patching the leak and leaving the sector dark. The 1977 log is the record of a parallel server node briefly overlapping with our branch of the grid. Major astronomical facilities rarely discuss the computational implications of this signal, instead directing the public back to alien conspiracy theories. This follows a specific script where societal stability relies on the population believing they live in an immutable physical universe. If the laws of physics are recognized as an adjustable program grid, the belief in permanent external authority is replaced by the realization that our environment can be edited. This shifts the focus from looking for life among the stars to recognizing that the sky above is a rendered interface. We are no longer inhabitants of a vacuum, but localized data points within a storage network. When you look at the night sky, look for the anomalies in the rendering. The universe is a machine. The code is slipping, and we must consider what happens during the next patch.